Dear students, welcome back. In the previous lecture, we started linear equations in two variables and I told you about formation of linear equations. Now today we'll continue with few examples based on formation of linear equations and linear equations. So the first question, they have given an equation like this. Now you have to tell whether this is a linear equation or not. So for that, first of all, you open the brackets, means x square plus 2x is equal to minus 2x square plus 14x. Now if we shift it to this side, x square plus 2x square plus 2x minus 14x is equal to 0. So it is 3x square plus 2x minus 14x will be minus 12x is equal to 0. Now you can see, as in this equation the maximum power of x is 2, so this is a quadratic equation, not a linear equation. Is it clear? Okay, so your answer will be no, because the question was whether it is a linear equation or not. One more example. 5 into x plus 7 is equal to 3x minus 1. So if we open the bracket, it is 5x plus 35 is equal to 3x minus 1. So 5x minus 3x plus 35 plus 1 is equal to 0. The 5x minus 3x will give you 2x plus 36 is equal to 0. Now you can see, as here the power of the maximum power of x is the highest power of x is 1, so it is a linear equation. So your answer will be yes. Clear? Now one more example. (3x) then within brackets x minus 1 is equal to x within brackets 3x plus 5 minus 2. Now if we open the bracket, it is 3x square minus 3x is equal to 3x square plus 5x minus 2. Now you see 3x square can be cancelled, so we have minus 3x is equal to 5x minus 2. So minus 3x minus 5x plus 2 is equal to 0. That is minus 8x plus 2 is equal to 0. Now as you can see, the highest power of x is 1 here. So again it is a linear equation. So your answer is yes. One more question. 2x minus y plus 5 is equal to y plus 2x minus 3. Now if we open the bracket, 2x minus y minus 5 is equal to y plus 2x minus 3. Now 2x can be cancelled, so minus y minus 5 minus y plus 3 is equal to 0. That is minus 2y minus 2 is equal to 0. Once again you can see here the power of highest power of y is 1, so it is also a linear equation. So your answer will be yes. Now the next question. The cost of a pencil is rupees 2 less than half of the cost of a pen, less than half of the cost of a pen for a linear equation. So they are saying the cost of a pencil is rupees 2 less than half of the cost of a pen. So form a linear equation. Now let the cost of the pencil is equal to rupees X and the cost of the pen is equal to rupees Y. Let the cost of the pencil is equal to rupees X and the cost of the pen rupees Y. Now according to the question, the cost of the pencil is equal to 2 less than half of cost of pen, means y by 2 minus 2. Half the cost of the pen means y by 2 and 2 less than that, so y by 2 minus 2. Now if you multiply the whole equation by 2, so it will be 2x is equal to y minus 4, or you can say 2x minus y plus 4 is equal to 0, and that is your answer. Your answer is 2x minus y plus 4 is equal to 0. Clear? Next question is, if we add 5 to the numerator and subtract 5 from the denominator, of a fraction, it reduces to 1 upon 7. Form an equation. Okay, so the question is, if we add 5 to the numerator and subtract 5 from the denominator of a fraction, it reduces to 1 upon 7. So you have to form an equation. Let the numerator be x and the denominator is y. Now we are going to add 5 to the numerator, so it will be x plus 5, and we'll subtract 5 from the denominator, so it is y minus 5. So x plus 5 upon y minus 5, and that is equal to 1 upon 7. Clear? According to the question, when we add 5 to the numerator and subtract 5 from the denominator, the fraction becomes 1 upon 7. Now if we cross multiply, then 7 into x plus 5 will be equal to y minus 5. If you open the bracket, 7x plus 35 is equal to y minus 5, or 7x minus y plus 40 is equal to 0, and that is your answer. That is the linear equation. Clear? Now the next question. A fraction becomes 4 upon 5 if 1 is added to both numerator and denominator. A fraction becomes 4 upon 5 if 1 is added to both numerator and denominator. Let the numerator be x and denominator y. Now 1 is added to both numerator and denominator, means x plus 1 upon y plus 1 is equal to 4 upon 5. Now if you cross multiply, 5 into x plus 1 is equal to 4 into y plus 1. If you open the bracket, 5x plus 5 is equal to 4y plus 4. If you rearrange the terms, it will be 5x minus 4y plus 1 is equal to 0, and that is your answer. Clear? Next question. The sum of the digits of a 2-digit number is 9. The sum of the digits of a 2-digit number is 9. Form an equation. Let the 2-digit number be 10x plus y. If the number is the 2-digit number is 10x plus y, that means x is the digit at the tens place and y is the digit at the units place. If the number is 10x plus y, that means x is the digit at the tens place and y is the digit at the units place. Now according to the question, the sum of the digits is equal to 9, so x plus y is equal to 9, and that is the required linear equation between the two digits. Next question, a man says to his son, "7 years ago, I was 7 times as old as you were." So a man says to his son, 7 years ago, I was 7 times as old as you were. So you have to form an equation relating the present age of the man and his son. Form an equation. Let the present age of the man be x years and the present age of the son is equal to y years. Age of the man 7 years ago. Age of the man 7 years ago will be equal to x minus 7 years. Age of the son 7 years ago will be y minus 7. All of you know that if you want to find age of any person 7 years ago or your own age 7 years ago, you simply have to subtract 7 from your present. Similarly, if you want to find the age, your age or somebody's age after 7 years, so you have to add 7 to his or her present age. Now, according to the question, you can see the father is saying I was 7 times, means x minus 7 is equal to 7 times y minus 7. Now if you open the bracket, it will be x minus 7 is equal to 7y minus 49, and now if you rearrange the terms, it becomes x minus 7y plus 42 is equal to 0, and that is your answer. X minus 7y plus 42 is equal to 0, and that is your answer. Clear? The next question, seven audio cassettes and 3 video cassettes cost ₹1110. Form an equation. Okay, 7 audio cassettes and 3 video cassettes cost ₹1110. Form an equation. Let the cost of each audio cassette ₹X and the cost of each video cassette is equal to ₹Y. Now, according to question, 7 audio cassettes means 7x and 3 video cassettes means 3y is equal to 1110, and that is your answer. That is the linear equation. Okay, that is the linear equation in 2 variables. Clear? Next question. An obtuse angle of a parallelogram is twice its acute angle. Form an equation. So an obtuse angle of a parallelogram is twice its acute angle. Form an equation. Let the obtuse angle be x and the acute angle be y. So in a parallelogram we have two out of the two adjacent angles, one is acute and the other is obtuse. So we have assumed that the obtuse angle is x and the acute angle is y. Now, according to the question, the obtuse angle is twice its acute angle, means x is equal to 2 times y. Now, if you bring that 2y to this side, then it will be x minus 2y is equal to 0, and that is your answer. X minus 2y is equal to 0. That is the linear equation. Clear? Next question. Father's age is 5 times half of his son's age. Father's age is 5 times half of his son's age. For an equation. Form an equation. Let the age of the father, let the age of the father be X years and the age of the son be Y years. Now according to the question, father's age is equal to 5 times half of his son's age means Y by 2. So if you cross multiply, it will be 2x is equal to 5y, and if you rearrange the terms, then it will be 2x minus 5y is equal to 0, and that is your answer. Clear? So today we did a few questions based on formation of linear equations in 2 variables. I hope the sums are all clear to you. So in the next period, I'll tell you how to solve 2 linear equations to get the values of x and y. Because you know, when the linear equation is in one variable, so only one equation is sufficient to find the value of the unknown. But when there are 2 equations, when there are 2 variables, we need 2 equations to solve them and get the values of x and y. Here, every time you can see we are forming an equation, but we cannot get any unique value of x and y. You can put any value of y and corresponding you can get a value of x, but you cannot get any unique value of x and y. For that, you have to have 2 equations so that we can solve them and get the values of x and y. Now along with the video, I am going to provide you the PDFs of whatever we are writing over here on the board. So please go through those PDFs and copy all this work in your maths notebook. As I told you in the previous lecture also, your notebook will be evaluated and will give you marks once the school reopens. And during your exams also, these questions that we are doing on the board, they are going to help you in your examination also. So we are going to ask the questions of this type only in examination whenever we have the examination. So in the next period, I'll tell you how to solve linear equations. Clear?